Hello, everyone, and a very good evening. Dear authors, session chairs, and invited guests, welcome to Technical Session 10D. Myself, Samriddhi Mogal, and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and Geoscholastic, it is my great pleasure to welcome you to the 10th World Conference on Information Communication System, Software Security and Sustainability, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was successfully held yesterday in London, UK, and the virtual event is being conducted through Zoom from 29 to 30 July 2026. I hope you all enjoy today's informative, insightful, and interactive technical session. In this session, we have six paper presentation. Each presenter will be allotted 12 minutes for the presentation, followed by 3 minutes for the question and answer session. I will give a gentle reminder when 10 minutes have elapsed to help you manage your time. I would also like to request all participants to kindly stay connected with us until the closing remarks of the session. If you have any queries or require any assistance during the session, please feel free to write to me in the chat box. Before we begin the presentations, I would like to introduce the distinguished session chair for this technical session. Today we have Dr. Napat Sukthong, sir. Dr. Napat Sukthong is a lecturer in the Department of Computer Science at Mahasarkham University, Thailand, with over 22 years of experience in higher education and computing research. His research interest encompasses machine learning, artificial intelligence, cognitive science, and knowledge reasoning. May I now request our respected session chair, Dr. Napat Sukthong, sir, to kindly share a few words with us and offer their valuable insights.
All right. It is a great pleasure to welcome you to the technical session 10D. I'm Tapasak Tong from Hasarkam University, Thailand. And I will be chairing this session together with Professor Priyanka from Mar University, India. We are pleased to have an excellent group of presenters with us today, covering several timely and important research topics. And we hope you find the presentation informative and discussions productive. Thank you very much.
Thank you so much, sir, for your valuable guidance. Our next session. Our second session chair is Dr. Priyanka Verma. Dr. Priyanka Verma is a professor at Purnima University, Jaipur, India, with over 20 years of experience in teaching, mentoring, and student development. Her areas of expertise span web designing, data mining, communication skills, leadership, and teamwork. A seasoned researcher, Dr. Verma has published extensively in reputed journals including InterScience, IEEE, Elsevier, and Taylor and Francis. She also contributes to the academic community as a member of editorial boards for several scholarly journals. I request ma'am to please share a few words with us.
Thank you so much, Samriddhi, for that wonderful introduction. And hi, Dr. Napat, how are you? Looking forward to co-chair this session with you.
Yeah, my pleasure.
And here's wishing all the best to all the participants. Looking forward to all the presentations.
Thank you so much, ma'am. Now let us begin with today's paper presentation. I would like to invite our first presenter, uh, Ali Rahman, with paper title A Quantum Secure, Smart, Energy Efficient, Sustainable Blockchain Ecosystem for the Deficient DeFi Industry. You may start your presentation. Mr. Ali, are you there in the session?
Yep, I'm here. Sorry, I was having issues with my mic and the
Oh,
audio, but
no problem. You can start your presentation.
okay. Give me just 1 second. Um, Are you able to see my screen?
Yes, sir, your screen is visible.
Okay, perfect. All right. Well, thank you. Good morning, afternoon, everyone. I'm Ali Rahman from Cloud Technologies. There's a phase in security circles. Harvest now, decrypt later. Adversaries are recording today's encrypted traffics, betting that tomorrow's quantum computers will unlock it. For decentralized finance, the bet is existential. So today, I'll present to you quantum ledger technology, or QLT, an architectural answer to a problem that cryptography alone cannot solve. DeFi today faces three converging pressures. First, the quantum threat. Quantum computing may undermine the public key foundations that every blockchain relies on. Second is security itself. Exposed credentials and complex software stacks are where real attacks happen. And third, sustainability. Energy efficient infrastructure is just no longer optional. Our position is simple. Future blockchain ecosystems must be secure, sustainable, and efficient at the same time. Let's look at the limits of current approaches. The industry's answer so far is post-quantum cryptography. To be clear, PQC is necessary. QLT complements it. It does not replace it. But PQC strengthens the math. It does not shrink the machine. Even with perfect algorithms, we still carry trusted software complexity, layered dependencies, exposed authentication surfaces, and architectural overhead. Most real-world exploits attack the implementation, not the mathematics. So our key question, can architectural simplification improve security and efficiency at the same time? So here's our core hypotheses. Reducing trusted software complexity and software-mediated trust may deliver four things at once. Number one, security, a smaller attack surface; efficiency, with leaner operations; resilience, support for quantum-resistant infrastructure; and sustainability, lower resource requirements. All of this while maintaining full blockchain functionality. That is the claim we are testing. So introducing again QLT, quantum ledger technology, is a blockchain agnostic framework integrating three core technologies. Zero vulnerability computing. This is the design philosophy to eliminate attack surface by architecture, not by patching. 3 SoC, or solid state software on a chip, moving critical software into immutable hardware. And Kreka, quantum resilient, user evasive cryptographic authentication. One objective ties them all together: shift trust closer to the hardware. Why does software complexity matter so much? Because more layers mean more risks. An embedded Linux stack runs 5 to 10 million lines of code. A real-time OS, hundreds of thousands. Actual operating systems like Windows goes from up to 50 million lines of code. Our projected QLT minimal runtime will be 20 to 50,000. Note the word projected. This is a design target, and validating is part of our evaluation plan. By minimizing OS dependence, limiting third-party permissions, and routing authentication in hardware, QLT creates a shorter, more constrained, trusted execution path. Lower exposure, leaner execution, more energy-aware infrastructure. So here's the architecture, end-to-end. On the left is the client layer, a ZVC or 3 SoC enabled device, hardware-rooted entry point. In the middle is the QLT tunnel, a constrained communication path, session-bound access only. Two gates control it. Gate 1 is device admission. Gate 2 is session authorization. And on the right, the server layer inside a perimeter control layer. Only authenticated sessions ever reach the blockchain network. The whole point of this design, reduce exposed authentication surfaces at every layer, from the client to the tunnel to the server to the perimeter. Four principles drive every design decision. Number one, a minimal trusted substrate so that you have less code to trust. Number two, a reduced software trust and third party permissions, fewer dependencies. Three, hardware rooted authentication. Trust begins at the device. And number four, energy aware design, less overhead by construction. Notice these are not features, they are constraints. They discipline the architecture. Now let's look at authentication. This is where QLT departs most sharply from current practice. Today, authentication is user facing. User manages credentials, wallets, and apps, mediate trust. Keys are a visible attack surface. Phishing, key theft, seed phrase loss, these are DeFi's biggest real world failures that we consistently experience. Cracker inverts this model. Device admission is concealed, authorization is continuous, not a one time login, and trust is rooted in the hardware. We call it user evasive. The human never touches the credential surface. So the credential surface cannot be phished. And the goal, the objective is user evasive, session bound access. Let's look at traditional systems versus Cracker. Side by side, the shift is clear. Traditional access, user to wallet to keys, every step is visible, and every step an exposure point. In case of Cracker, a concealed device handshake through gate 1, continued authorization through gate 2, all inside a controlled tunnel. The core shift in one line, from user-facing cryptography to user-evasive, hardware-rooted authentication. Now, here's a connection that people don't expect. Security and sustainability are usually framed as trade-offs. More security means more overhead. In QLT, they reinforce each other. Reduced trusted complexity means leaner execution. Leaner execution means less energy. The same simplification that shrinks the attack surface also shrinks the resource footprint. So security and sustainability are not competing goals. They share a root cause, which is complexity. So where does all of this apply? So we've taken a DeFi first approach, transactions, ecosystems that are quantum resistant by design, Web 3.0, self-sovereign identity and decentralized applications, IoT and 6G, quantum safe device with minimal overhead, built for low latency networks, and quantum as a service, quantum safe operations at scale without centralized trust. The framework itself is blockchain agnostic by design. It is infrastructure. It is not a singular chain. Let me be precise about what this research contributes today. Three things. One, an architectural framework, QLT, blockchain agnostic by design. Two, an authentication framework, which we call Cracker. And three, an evaluation framework, a hypothesis-driven model for comparative assessment. And I want to be clear and direct about where we stand. This is the hypothesis and architectural stage. Empirical benchmarking against the evaluation framework is the next phase, and I welcome collaboration from this community on that. So to conclude, security alone is not enough. Efficiency alone is not enough. Sustainability alone is not enough. QLT explores how architectural simplification can deliver all three: quantum resilience, sustainability, and secure digital trust for the next generation of decentralized system. So that's QLT, architecture-driven trust for the quantum future. And that's the end of my presentation. Thank you. I'm happy to take any questions.
Thank you. Thank you for presentation. Do we have any question from session chair?
Okay, I got one question. Could you clarify how the proposed Curator mechanism achieves quantum resistance? which pose quantum cryptographic algorithms like MLKM, MLDSA, or um, another security assumption or standards were used to validate it against quantum attacks.
There's a simple answer to this. Can you close the door, please? Simple answer to this. The way that a cracker works in terms of authentication is there's a singular gate, the primary gate, which requires a handshake between a physical device. This, by nature, is non-cryptographic. And without this initial authentication,
Right.
post-quantum sort of decryption becomes irrelevant in a
Uh,
situation, in a scenario as such. If the first gate is not passed, no quantum computer or quantum computing can actually break down the encryption because there's nothing encrypted at that point. So that's kind of the novelty of the design, where QLT can kind of work in conjunction with post-quantum computing. Yeah.
okay, okay. No more question. Thank you very much.
Ma'am, do you have any
Ali,
question?
can you just tell me about the data sets that you have used for working on this particular architecture?
What kind of data sets do you mean? Because a lot of
This architecture, have you implemented it?
we have been experimenting with a lot of things. We have published a few research papers, and we're in the process of implementing a lightweight version of this. There's different initiatives here. One is the hardware aspect, which is three SoCs as we described. That's a more of an extensive kind of initiative of implementation because that goes all the way to the hardware level. Yeah.
So that means you have not yet implemented it, right? And any specific threads that you are targeting?
Well, so any kind of malware, the key kind of implication of what we've been working and researching is reducing attack surfaces for malware exploits. We've been looking at DeFi. That's sort of the background that I have, that I've been working in the industry for the last several years. And so we are trying to ensure that the exploits or hacks that happen as a consequence of improper signature or signing of transactions, how can we minimize that? Because that's basically taking advantage of someone's third-party permission. So we're
Okay, so you
experimenting and
mean to
piloting that
say,
with custodians. Yeah,
okay, so you mean to say you're working with digital signatures, right?
correct. Yeah. I mean,
Okay.
that's one of the implementations that we're actively working on. We've been working and collaborating with several centers of excellences in research universities all across Europe, specifically for Cracker and ZVC. And so we're kind of like combining our shared knowledge together to have some applications that we can actually reality test in the coming months.
Okay, fine. Thank you, Ali.
Thank you.
Thank you so much, ma'am. Thank you so much, sir. With that, let's move on to the next presentation. Our next presenter is Gurtal Airtech, and the paper title is Benchmarking E-commerce Product Characteristics Through a Novel Multi-Phased Data Analyst Framework. You may start your presentation, sir.
Hi there. My video is from my telephone, and I asked for screen sharing from my computer. So could you please give screen sharing access to Gürdal Ertek rather than iPhone 19? Can everybody see my screen?
No, sir. Please
no.
share your screen, then I'll allow.
Okay, let me try again. There we go.
Your screen is visible, sir.
Yes, just trying to shoot. This is how. Okay. All right. So let's get started. I have 12 minutes, right? All right. Hello there. My name is Dr. Gurdal Ertek. So my screen is under Gurdal Ertek, but my video is under iPhone 19. So if you want to see me. So this our study is a joint study with our students, and our students, master students, Shamsa, Muna, Maryam, and my colleague, Dr. Hana, Hana Ohabi, and myself, Dr. Gürdal Ertek. And we are from the College of Business and Economics at United Arab Emirates University in Al Ain, UAE, United Arab Emirates. So this is the topic of our research, as you can tell from the intro photo, splash photo, is the e-commerce. So what have we done in this study? So as you know, there's vast amount of data available for e-commerce. So what we did was we obtained this data and we benchmarked e-commerce product characteristics. And for this, we developed a novel data analytics framework that looks into different types of analysis. So that's what we did. So we have e-commerce data, and we want to benchmark the products, how they compare to each other, and especially products in different countries, products across regions even, and then draw conclusions. To be able to draw these conclusions, we need a data analytics methodology that has to be systematic, which is the contribution of our study. So e-commerce is growing very quickly still. Okay, so this is the growth projections from 2025 till 2034, which is approximately fourfold, 3.5-fold increase in 10 years. Okay, and there's already a vast amount of data available on prices, ratings, locations, and we can compare markets. And within the overall context of e-commerce, we also have the e-commerce in GCC. So what is GCC? GCC is actually countries in the Gulf Cooperation Council. Gulf Cooperation Council. You may also hear these as Gulf countries. Okay, so these are, of course, we are at UAE, United Arab Emirates, Saudi Arabia, and then Qatar. So there are 6 countries like this. I will not mention all of them. So these are the GCC countries that are the topic of this research. Okay. So what is the research problem? Okay. So e-commerce data combines different characteristics, but only in the past they were looking only at limited areas, not all of these areas at once. So there was no study that was found to combine statistical distribution fitting, group comparisons, and text mining, or in other words, text analytics, in a single unified process. So our research gap is basically to come up with a unified process, a unified framework that combines 3 aspects: distribution fitting, group comparisons, and text mining. Okay, and these are the earlier work. Again, all the earlier work, they are either looking into statistical descriptive analysis, or they are looking into comparisons or another statistical method, or they are just doing text mining. But we are combining all of these in a systematic way. Okay, so the source of the data set is a commercial provider, which is called Find Niche. Okay, Find Niche, and they have data on different e-commerce platforms, including, as far as I remember, they also have on other e-commerce platforms, but we only choose AliExpress. So data pertaining to AliExpress only, and this is the data provider. And this is the source of data. Okay, so these are the products on AliExpress, but the data set is coming from Find Niche, which has scraped that data and made it available for us. So there are around 5,000 product records, 4,800 product records, and we filtered 9 countries, which are 6 of those countries are the 6 GCC countries in the Gulf Cooperation Council. And we also selected 3 non-GCC countries. So these are the countries in the GCC. But how come we selected these other countries? Why do we include them? Because these are countries that send many, many expatriates to the GCC region. For example, in the UAE, the Emirati citizens, which are the UAE citizens, they are only 15% of the population, but the remainder, 85%, is coming from other countries like myself. I'm also an expatriate, and I'm from Turkey originally. and there are many expatriates from these countries, Egypt, India, and Philippines. Of course, there are also other countries as well, but we just wanted to select these specific countries, like one from Africa, North Africa, one from Indian subcontinent, and one from Far East. So that's how we select. Okay, and again, the insights that we derive here in the case study, they are very helpful, but the main contribution of the research is not saying, oh, okay, this is higher in Philippines compared to Egypt. No, the main contribution is there is now a methodology like this that companies, analysts, and also academicians can use to analyze markets. Okay, all right. So again, the source is Finish Data and Analytics platform, and it's listing the products from AliExpress. Of course, there are not only 5,000 products. This is in a certain time window only. Okay, and these are the attributes. So we have the minimum price in that time frame. We have the maximum price in that time frame. Then we have the rating for that product, engagement data, release data, other data. Then based on the original data attributes, we come up with some derived attributes. Derived attributes means using the existing attributes, we make some calculations. Like, for example, max div min means maximum price divided by minimum price. So this is showing, for example, the variability. Is GCC means, is this a GCC country or not? So like this, we have some derived attributes as well. Okay. And the reason we select these non-GCC countries is because they send many expatriates to the GCC region. Again, this is probably the most important slide in the whole presentation. This is the framework. Okay, so it consists of the statistical distribution fitting, which is for univariate analysis. Then it consists of statistical comparisons, group comparisons, and then thirdly, it encompasses text mining. Okay, so these are the three things. So here, the first part of the framework is step one of the framework is to identify the probability distributions and to fit them into well-known statistical distributions. These are all continuous distributions, and we used this library for that. And these are the histograms, and then there's also the results of statistical fit as well. We also have that as table as well. The details are in the paper. The second one is comparison of some attributes across groups. Okay. For example, here we're comparing the max div min values across countries. Okay, so let me see if I can zoom maybe. Okay. As you can see, each of these box plots is showing a country. Okay, and for the x-axis here, this is the x-axis. Okay, these are the values for max divided by min. Okay, so these are the x-axis is the max divided by min, and the y-axis are the countries. Okay, so this is the first, of course, visual analysis, but then it has to be accompanied by proper statistical analysis as well. So to test whether at least one of them has lower or higher max div min value, we call this response. So is the response different for any of the countries? To test that, we use Kruskal-Wallis test. And the next question is, okay, if there is a difference, then which one of those are different from each other? Is Philippines? Does Philippines well, Philippines obviously has the least one, but is this, for example, Egypt has more, but is this difference statistically significant? Then India versus Philippines, is this statistically significant? So those are pairwise comparisons. For that, we use Dunn's post hoc tests. And then to visualize the results of those test results, we use dominance graphs. So here, for example, we can see for max div min across country. So for Philippines and Egypt, the maximum price divided by minimum price is low, very low. Okay, which means there is not a big multiplier. Okay, whereas for these countries, especially Bahrain, Kuwait, Qatar, and Saudi Arabia, there's a huge gap and statistically significant difference. These are the p-values, by the way. And this dominance graph shows that each arc shows that there's a statistically significant difference. Okay, and the third step is the text analytics, and we use two methods right here. We use word clouds, so this is a word cloud visualization. But then to determine the topics, we use a method called LDA, and then also to
Sorry to
compare.
interrupt.
Yeah,
Sorry to interrupt. It's a gentle reminder that you have only 1 minute left to conclude your
sure.
presentation.
I know. Thank you so much. And then, so we also had a generative AI to create the categories as well. So these are the findings. So these orange colors are the statistical significant differences. And also, by the way, we could have a country is GCC month as the factor, and the response could be price range, max div min, product rating. Okay, and these are some text analytics results. We can clearly see the two different themes are corresponding to two different product groups. Okay, so this is the first theme, and this is the second theme, and automatically identified by the text mining method of LDA. And we identified 30 product topics or product categories through text mining as well. And again, there are some other analysis that could be done. There are both theoretical and practical contributions of the study, and the study can be applied to any product set or country selection with similar attributes. And this is the first and only study that unifies these three techniques that could be applied: statistics, descriptive statistics, visual analytics, statistical hypothesis testing, and text analytics all together. This is the first time we see it in the literature. And there are many limitations of the study. And as a conclusion, this framework that we introduce allows us to have a comprehensive view of the e-commerce product data, and it could be applied in many other contexts. Thank you so much. I'm open to your questions and discussion.
Thank you so much, sir. Do we have any question from session chair?
Yeah, I got you first.
Yes, please.
Hi. I just wanted to know, have you worked on recommendations as well?
We did not. That's actually, there are many ways in this framework could be expanded, and I'm very happy that you mentioned that because it's actually my real expertise is recommender systems. Okay, so but we did not do that because we do not have fine granular data. Like we do not have the transactional data. We just have summary data. Like we don't have, for example, let's say the data set on transactions of each purchase. We just have data set on let's say total sales of that product. Like we have aggregated data, so that's why it's a bit difficult to see customer preferences. I mean, there could still be some recommendations, but yeah, I like recommenders systems a lot, but we didn't have a look into that because we thought we didn't have transactional fine granular data, but we only had aggregate data about the product, summary data for the products. That's why we only use these methods.
Yeah, because you mentioned text mining, no? So that's why I said that if you have worked with web mining and worked on recommendations as well, but you can consider it as your future work.
That actually, you're right. Here, for example, when we have these visualizations, okay, so it automatically created the topics. And of course, in the TF-IDF matrix, okay, in the TF-IDF matrix, and also for, one of the results is like it's telling us which product belongs to which topic, or in other words, which product belongs to which category. So if a person is purchasing from that category, one product, then we can recommend the other products in that category, maybe the one that is closest to it with respect to Euclidean distance or another distance metric. So yeah, it could, I mean, actually it's LDA results can directly be used as recommendations. I mean, that's a very good actual thing. That's a very good suggestion. Yeah, I think it would be nice if we had mentioned that.
Thank you
Any
so
other?
much, ma'am. Sir, do you have any question?
One more question for me. Since the dataset includes countries with different currency, market size, and numbers of product records, how do you normalize these differences to ensure fair and meaningful country-level comparisons?
Could you repeat the first part again?
Since your dataset includes countries with different currency, market size, and number of product records, how did you normalize these differences to ensure fairness and meaningful country-level comparisons?
Yes, wonderful. The data set automatically, the original data set automatically gives everything in dollar amount.
Oh, okay.
That's what I remember. But of course, even if that was not the case, which is the case, by the way, but which even if that wasn't the case, max div min is scale independent. So max div min doesn't care about the unit of currency. And product rating doesn't also care, but only for price range, it could be it could be a factor to take into consideration. As far as I remember, all the prices were converted to dollar automatically in find niche. And
Uh,
if there are no questions, can I also say something else?
yep.
I just realized I forgot to put that, but actually all of this data set again, as we said, it's coming from this platform called FindNiche, and this is a
Uh-huh.
online platform. And I bought this platform lifetime access from appsumo.com. It's very beneficial platform because there are some data providers, they also sell their services lifetime with lifetime deal at appsumo.com. I'm not doing advertising, I'm just saying I found very good data sets from AppSumo. This is one of them, and the other data sets there's another data provider, and I have been able to write so many papers just using these platforms that give me lifetime access, and I'm just paying a certain amount at AppSumo. So it's very beneficial. So for us, it's very hard to find data sets at a low cost, and so we have to go lifetime deal. So there are sometimes these data providers under appsumo.com. So if you're interested in finding similar data providers, please check out that company as well. It's a very nice. It really helped my career a lot. So hopefully it will help yours as well.
Okay. Before you using this data set, do you have to do like data cleaning?
We assume that the data is already clean.
Oh, okay. Okay.
We did some data cleaning, like just there were some missing values, etc. Those type of things we did, but the values themselves, for example, price values, ratings, etc. We assume that they are correct. We didn't do any cross check. We didn't do validation.
So there's no missing values or something like that.
There were missing values, of course. There were missing values. We handled them in different ways. I can't go into details, but yeah. We did for some of them, for example, we removed the rows that we had to remove because we didn't want to do prediction of the missing values. We didn't want to do that. We just, filtered only the existing values. So.
All right. Thank you for your answer.
Thank you.
No more
Thank you. Yeah, of
question.
course,
Thank
there
you.
was some data cleaning. All right. Thank you so much.
Thank you so much, sir. Thank you so much, ma'am. Let's move on to our next presentation. Our next presenter is Ranjit Bidwe, and the paper title is Employee Attrition Prediction Using Machine Learning Techniques. You may start your presentation, sir.
Hello, am I audible?
Yes, sir, you're audible.
Okay. So, hello everyone. My name is Tanmay Kulkarni, and I am here regarding my project that is predicting employee attrition using machine learning techniques. So, what our project basically works on that whenever any employee leaves the company, so the company faces majority of major losses. So, our model tries to examine and detect that which employee will leave the company based on machine learning models. So I would continue. So the abstract problem statement, as I said, that an employee attrition refers to that employees leaving company based on means wait, excuse me. Hello, hello.
Yes, sir, you're audible.
Yes. So as I said that employee attrition here refers to employee leaving a company voluntarily. So we used data set of IBM HR Analytics, which had a data of 1470, that is 1470 employees and 35 features. So the 35 features here are the features which impact the employee leaving the company, like the age, monthly income, job role, overtime, work experience, and marital status, or the distance from the company. So what I want to say is that these are the factors which influence the employee leaving the company. So these were the 35 features, and this was the total number of data on which we performed our operations. After that, before our model, there were three early benchmarks, and out of that, the latest one was from the Felucci ETAL 2020, which achieved an accuracy of 82.5% and a recall of 0.54. So the recall here refers to that which company are actually leaving the company, and it was 54.1%, which was relatively very lower as compared to the recall that we achieved, which was 70.4%. Then the proposed architecture, we here used an architecture of TDSP, that is Team Data Science Process, and it is a five-step architecture which includes data acquisition, feature pre-processing, exploratory analysis, model training, and deployment in real time. So in layman language, if I want to explain it, that it was like that we get the data, we clean the data, then we explore it, means like reducing the null values, which also comes in pre-processing and feature engineering. Like that, we are removing the null and zero values, the tables which do not affect the running or the execution of algorithm, then building the model, deploying it, and finally a smart and a smart team of model was implemented. Then comes the data acquisition and pre-processing. The IBM HR Analytics dataset which we used didn't have any zero missing values. But then also we tried to remove some features which did not impact or which do not impact the factors leaving employees. Means these factors are not influenced by the employee leaving the company. Like employee ID, it has nothing to do with the employee who is leaving the company, right? Then over 18 indicator, hourly, weekly rate fields. So these all factors were removed. After that, we converted the data to 80-20%. Like 80% of the data was used for training and 20% was used for testing. Like 1716 was used for training and 294 was taken as test sample. Then after that exploratory analysis, that here we examined the key factors which influence an employee leaving a company. Like the employees with lower income had the high attribution rates. Then the employee which had to work overtime almost showed three times more attrition than normal. Then younger employees and employees with less than two work experience showed gradual shift to other companies, and hence they also showed high attrition. So after that comes the main part of our project, that is the model. We here use the stacking ensemble architecture, in which we used five models combined together working as a single model, which we call the stacking ensemble. The five models which we used, or the five algorithms which we used, machine learning algorithms, are XOR trees, gradient boosting, logistic regression, AdaBoost, and random forest. So the inputs or the output from this model served as the input for the stacking ensemble, and hence it overall increased the accuracy of the project or of the outcome. Also, I would like to say that each of this model prediction became input for the logistic regression meta model, and it overall improved the accuracy and also tried to enhance the recall, as the previous models only use Gauss, naive, or individually gradient boosting. But as our model was using five different algorithms, So it overall increased the recall score from 54% to 70.2%. Sorry. Then as experimental result, this was the latest and the most accurate model, that is Falucci ET.AL. And it had an accuracy of 82.4%, but as you can see, the recall was 54.1%. So as our stacking ensemble model, 5 model stacking ensemble, had an accuracy similar to the Falucci ET, that is 83%, but the recall was highly increased from 54 to 70. As you can see, a 16 percentage point increase over here means that our model was able to detect more relatively or more accurately that which employees are actually leaving the company. And then for the threshold optimization, we tried and using different thresholds. And after that, we tried to catch an accurate or a most optimized threshold, which was of 0.25. And so, and before that, I would like to say that when we use different threshold, it affects the model performance. When you keep the threshold lower, it increases the recall, but it also increases false positive. False positive means the company means flagging the employees which are actually not leaving the company. And when you keep higher the threshold, it increases the precision, but of course, and of course, it misses the employee which are leaving the company, which is indeed recall. So we kept a threshold of 0.25, and it provides the best balance between recall accuracy and F1 score. And then the confusion matrix, that after we performed the model, 33 of 47 actual levers correctly identified, and recall was of 70.2%. So any questions?
Do we have any question from session chair?
Yeah. Burst mode and all pre-processing steps performed separately within each cross-validation training flow to ensure that no synthetic information leaks into the validation data.
Sorry, sir. Can you please repeat your question?
Burst mode and all pre-processing steps performed separately within each cross-validation training flow. When you do this mode process.
Sir, actually, I am not able to get what you want to say. Can you please? Hello?
Hi. Okay. Maybe next question. Since the model was trained on a relatively small IBM HR dataset, how
Yes, sir.
would you
Yes, sir.
validate it in a real organization
Yes,
and
sir. And sir,
assess?
actually, we use this IBM HR analytics dataset because we did not get any more broader or a more diverse dataset. So, while using this in real life applications, we will of course increase the number of means the number of what I can say that the more values in dataset and also features. Like here, we just use 35 features, which of course cannot define that which employee will leave the company or it will stay. So when we will increase the amount of entries in the dataset, we will also try to increase more features. And when we increase more features, we will also try to randomize and give weightage to the features which are affecting the employee attrition more. So whenever we will get the data set, we will have to increase the features and we will have to perform maybe instead of 5 stack ensemble, we will have to increase it to more two or 1 or 2 algorithms, and hence we can work on it because we didn't get any more classified and clean data set other than IBM HR analytics for this
All right.
problem statement.
Okay. No more question from me.
Hi, I just
Yeah.
wanted to know, did your data set introduce any bias as well, and was it balanced?
Yes, ma'am. The data set had a bias, and hence we used SMOTE to create the imbalance. As there was 84% of the employees which were actually staying, and 14% of the employees were leaving. So we used SMOTE to balance the imbalance which was happening due to the data means we use SMOTE to correct the incorrectness or the imbalance in data.
Did the employee retention improve after implementing your model? Have you
Yes,
implemented
ma'am.
it?
Before the data pre-processing means before we, excuse me, let me share my screen, ma'am. Ma'am, before reaching to exploratory analysis, we tried to clean the data, and before cleaning, we use mode. And when we use mode, so the data got at equal balance level, and hence it increased the overall accuracy of the data at 70%. Because if we wouldn't have done that, so it would have shown by us as 86% of the employees not actually leaving. So the recall would have been significantly lower as compared to 70% if we wouldn't have used Smoot in earlier process.
Okay. Okay, fine. Thank you, Tanmay.
Yes, ma'am. Thank you. Thank you, everyone.
Thank you so much, ma'am. Thank you so much, sir. With that, we'll move on to the next presentation. Our next presenter is Amol Kamre, and the paper title is Multimodal Emotion Recognition System Using Deep Learning. You may start your presentation, sir.
Hello, can you hear me?
Yes, sir, you're audible.
Uh, my screen is visible.
Yes, sir, your screen is visible. You can start your
Yes.
presentation.
Our title is Multimodal Emotion Recognition System using Deep Learning. So the abstract is for any human-computer interaction. It is pretty important for emotion recognition, and convention facial expression only rely on visible emotion cues, which pertains them from understanding the physiological emotions as well, which is what we are trying to address in our problem. So the more here we assess through the facial emotion using CNN, as well as heart rate variability using max 30102 plus Arduino. Uh, so both the modalities are combined using circumplex model of effect and decision level fusion, which allows you to identify the emotions such as joy, stress, anger, hidden anxiety, focus, calm, relax. So intelligent systems like CNN allow us to understand human states, but these monitor external emotional behavior and fail at understanding the physiological, for which we have proposed our model, which take it from only the CNN, which recognizes the facial emotions, to the physiological signals, which are fused together, both these signals, to evaluate the final emotion, which is done using the sensor. So this is the current literature where facial CNN is available. So our proposed methodology is using the standard webcam, which approximates the facial emotion, and using max 30102 ppg sensor, which evaluates your heart rate. The dataset which we have used is for 2013, which contains over 35,000 facial images with 7 labels of data in varying emotions, anger, anxiety, etc. And the facial emotion is evaluated using the CNN, which receives for 48 into 48 pixel grayscale images, and the arousal is measured by the max 30102 detection sensor. And at the final, once the face emotion and arousal are received, a decision level fusion occurs, in which the facial valence and physiological arousal is combined in a circumplex model, which gives us the final emotion. Our system architecture is that it receives a multimodal input from the webcam and the sensor, the facial detection is done and converted into 48 pixel grayscale image. The CNN evaluates the facial emotion through the dataset which it was trained for 2013. In the same time, the max detection sensor using Arduino Uno does a signal filtering and evaluates the arousal, goes through the fusion engine and circumplex model, and the final emotion is generated. So the circumplex model, as I said, it is in a way x and y axis. So if the facial state is positive and arousal is high, here the emotion is joy and excitement, and here you can see. And for the uh, high BPM and low BPM, we have kept fixed values for evaluating whether uh, the arousal is high or low. So here is the simulation result. 98% success rate. The CNN inference is 72% success rate, and heart rate is at 95% success rate, and fusion logic is 100%. So these are the other literatures which we are compared, and this is the proposed is our evaluate. While you can see the accuracy may not outperform by huge margin or not in some cases, what our focus was in this project was that we create an affordable, easy to implement software which is inexpensive and you can easily understand it, not to make a complex architecture and an extremely expensive hardware which can't be done by easily reproducible, which isn't easily reproducible. We have done an inexpensive version of it. So to conclude, facial expression cannot be reliably marked only by the emotions, but our proposed system that's why combines the facial emotion along with the uh, heart rate, and we also have done a normal data set training and validation split, and the validation to achieve a 64.8% accuracy overall. And this is done completely to a low cost solution rather than focusing on high tech hardware. So which allows it to be a practical real time usage. So in future, rather than using the fixed BP and heart rate, we attempt to use uh, a threshold which will be based on the resting heart rate of the patient or whoever the user will be, and deploy the pipeline or embeddable or wearable edge where, and also attempt to go for wireless hardware which is a more expensive hardware, and cross validation of the dataset through other dataset rather than self validation of the datasets training and validation dataset. We can go for cross validation as a future validation parameter. Thank you.
Thank you so much for presentation. Do we have any question from session chair?
Okay, maybe one question from me. How are the BPM and HRV thresholds for low, medium, and high arousal determined? Were fixed threshold applied to all participants, or was an individual baseline calibrate performed?
The fixed threshold was applied. Right now, we have applied a fixed threshold of 105 heart rate, which is like a medical, not evaluated, but a normal standard, which is considered as a high BP, high heart rate measure, 105. So we have planned for future scope. Our patient's heart rate resting heart rate can be used as the threshold for evaluating in the future. But right now it is a fixed threshold at 105.
All right. Since the FER 2013 contains only facial images, how do you create the synchronized webcam? Let's say PPG evaluation datasets, and how were the gradual emotional states assigned for evaluating the complete multimodal system?
I'm sorry, could you repeat?
How did you create and label the synchronized webcam? Do you have um, let's say PPG test data?
The images were clicked from the webcam. The webcam was used to click images and were uploaded to the CNN, where on its already trained dataset we evaluated our images, which were uploaded as photos.
How do you synchronize or merge those facial image and the webcam?
I mean, the normal web app was used, which could intake the images from the webcam. I mean, the laptop was connected with the app using a web app, which transmitted the images to the model.
Mhm. Could you elaborate your answer? Give give me some more details.
Okay. So, I mean, the app was started using a normal web application, how we make using React or React framework. So, uh, give camera access to the web app. It opens and keep a button which click the image using the camera or webcam of the laptop, and those images are saved on the device, and those images can be sent to the model for evaluating. So that is our basic way how we performed our experiment.
Okay, no more question from me.
Ma'am, do you have any question?
No, no questions from my side.
Thank you so much, ma'am. Thank you so much, sir. With that, we'll move towards our next presentation. Our next presenter is Caio Tertulliano Ribeiro. The paper title is Structured Fairness Aware XG Boost Tuning for Banking and Credit Datasets via NBI Style Sampling. You may start your presentation, sir.
Hello, can you hear me?
Yes, sir, you're audible.
Okay, I'm going to share my whole screen. Just a second. Can you see the presentation? Could
Yes,
someone
sir,
just
your
confirm
screen is
that
visible.
my screen's
Yes, sir, your
okay?
screen
Thank
is
you.
visible.
Okay, so hi, my name is Caio. I'm a PhD student here from Brazil. Today I'm going to present my paper, which is a case study that derives hyperparameter tuning method for tabular machine learning, specifically in binary classification that derives from my master's thesis, which I came up with. We will get these mechanics and introduce it into a financial case studies on which We are applying a structured fairness-aware XGBoost tuning for banking and credit datasets using navigation of trade-offs via normal boundary intersection style sampling. So the reason we choose financial problems is which the inheritance of the trade-offs involved into the machine learning metrics involved in such problems. That meaning optimization goals for the machine learning metrics can be conflictual. That meaning, meanwhile, you want to maximize predictive utility, you also want to minimize, for example, proxies for fairness, such as group disparity, which is a known metric for calculating bias into classification problems. Okay, so the reason is the majority of optimization techniques for hyperparameter tuning in machine learning are like standalone application of just one objective goal. That's meaning you probably will have to pick like accuracy or any other only metric on the confusion matrix. That meaning in such problems like this, the accuracy alone, maximizing accuracy alone is insufficient because we have disparity between groups. We have imbalanced data sets. And also, thresholds and class weighting can dictate the final operating points for the supergroups in such problems. And as already mentioned, the standard stochastic tuning obscures the shape of fairness performance frontier. So our research question was, can structured search effectively map fairness trade-off under a fixed budget? So jointly tuning conflictual objective goals and parameters, thresholds and weights is computationally expensive. And the goal of introducing this mechanism is to replace like black box stochastic guessing with a white box approach, interpretable and geometry-driven surrogate exploration of the hyperplane of the possible combinations of a hyperparameter optimization problem. The focus in a financial-driven problem is to provide reproducible, explicit decision support for lending and credit governance, reducing bias into credit predictive algorithms. We use three different data sets with different amount of samples, different amount of features, different patterns of imbalance, as you can see on the positive class. All of them with protected classes and different target associated scores. The methodology for this method, we applied a mixture of integrating experimental design with frontier sampling from normal boundary intersection. So the starting point is a 152-point design of experiment using specifically fractional central composite design. With the results of this pre-mapping of the hyperparameter space, we use 5-fold cross-validation with surrogate fitting, generating quadratic response surface models. And with the coefficient of the response surface models, we do a normal boundary intersection style sweep. That meaning geometric sampling over normalized surrogates from the response surface model fitting. There is a post-optimization part step on which we do local refinement with anchor-based Gaussian perturbations on the that all to avoid the optimization function to be stuck on not on the global maximum or minima. Finally, the selection of Pareto filtering via specific governance rules. So also the key innovation throughout the combining of these methods is also using threshold and scale positive weight being treated as primary search variables, not like a post-processing, post-optimization steps. Also in the methodology side, we did rigorous evaluation to guarantee fairness and matched evaluation budget between our method and the random search, which was the benchmark used. So we did 3 independent replicas with fixed seeds across the cross validation and also for the algorithm, the XGBoost algorithm, capturing objective noise in varied cross validation partitions. We did preserved folds with the protection class to protect the highly imbalanced subgroups, and also matched budget. That meaning exactly final 882 model evaluations for both the proposed and the random search baseline. And also the optimization targets as conflictions, as mentioned before, is maximizing the balanced accuracy. Meanwhile, we minimize the disparate impact gap. We also computed some audit-only metrics for finance and classification problems, but those weren't involved into the optimization problem. Our findings with the appliance of this method is that the structure tuning consistently outperform the default hyperparameters of the library from XGBoost. That means on all the 3 data sets on both optimization goals. We have a statistical meaningful that we can outperform on both balanced accuracy and the minimization of the disparate impact gap throughout the 30 replicas. And the method also provides a structural transparency. But against random search, it's not, we couldn't infer statistically that it dominates this particular baseline. So it's effectively tied, matched budget with random search. But again, the good, what the innovation of this method is the transparency, so the white box approach, on which we can plot trade-off curves like this, and we can navigate the trade-offs of, for example, being able to have an explicit marginal decision of how much am I okay to give up of my predictive power to be able to have more unbiased results. So the goal is explicit mapping this trade-off geometry and power intentional decision making. Meanwhile, the design of experience guarantee active exploration of search space boundaries. So the evaluated frontier, as mentioned, enables this explicit model governance policies on which we can navigate through nadir and utopia points. That meaning the being able to assess multi-objective trade-offs into conflictual objective goals into machine learning problems, and having auditable compliance choice
Sorry
over a
to
null set
interrupt.
of candidates.
Sorry to interrupt, but you have
Okay.
only 1 minute left to conclude your
Okay.
presentation.
But that's it. The conclusion that we get is the joint tuning of hyperparameter thresholds and weights is vital to the controlling of the final operational point. Narrowing the objectives to disparate impact directly aligns the mathematical search with landing compliance realities, and the normal boundary intersection style sampling provides human decision makers with a reproducible map of the trade-off frontier under a fixed budget of evaluations. Thank you. Do you have questions?
Thank you so much for presentation. Do we have any questions from session chairs?
I have one question. If your performance is similar to random search, what practical advantage does the proposed structure method provide beyond transparency and reproducibility?
As I stated, we have the ability of navigating the trade-off between multi-objective conflictual goals. So, for example, we can't have both optimal points when we are talking about conflictual objective, multi-objective optimization problems. With this approach, we are proposing you can navigate the trade-off curve and have informative choice with the end results. Okay. Of course, there is just a minor. We evaluated only 3 data sets. A limitation of this research is that we could have used more data sets and compared against different benchmarks, not only random search. But those are initial findings. We plan to augment this research so we can have clearer answers. Make sense?
Right. Okay. Okay. Thank you for your answer. No more question from me.
Mm,
Hi,
Ma'am, do
I
you
just
have?
wanted to know, did you optimize your framework?
What do you mean by optimize? Yeah, we did applied optimization techniques. Is that the
Hmm.
question?
Yeah, so what all optimization techniques did you apply?
Sequential least square programming optimization method.
Okay. And your data sets that you used, were they publicly available or was it like connected from somewhere?
Yes, they are publicly available. Sorry to did not mention that, but they are either from UCI repository or Kaggle datasets, publicly available.
Okay. Thank you.
Thank you so much, ma'am. Thank you so much, sir. With that, we'll move on to our next presentation. Our next presenter is Gurtal Ertek, and the paper title is Vibe Coding of Analytics Dashboards, Lesson Learned from Two Case Studies. So you may start your presentation.
Hi, I believe everybody can see me right now, yes?
Yes, so your screen is visible.
Sure, sure. First of all, thank you again, and hi again. So this time I have another work that I'd like to present today, and the topic of the work is vibe coding. So what is vibe coding? Vibe coding is basically coding with AI, right? Coding using generative AI. Okay, so this is called vibe coding, and the term itself was coined in by the famous AI researcher Karpathy. So he himself used this term for the first time. Vibe coding is like, you're getting good vibes out of that. So it's basically vibe coding means coding with artificial intelligence, of course, generative artificial intelligence such as ChatGPT, Cloud, Kimi, etc. Okay, and vibe coding of what? Are we vibe coding mobile apps? No, we're vibe coding analytics dashboards. So analytics, as we know, is the modeling and analysis of data. So the topic is vibe coding of analytics dashboards, and we have 2 case studies, and we have learned some lessons regarding, the usage of vibe coding for development of analytics dashboards, and this is the topic of this presentation of this research. Okay, and nobody has done this before. I mean, there are studies in the literature where they looked into vibe coding, and they communicated their experiences using vibe coding for coding. But there's no study at all that used and that used vibe coding for developing analytics dashboards and explained their findings in 2 different case studies, especially that one didn't exist. So that's the first work that's in the literature. So our lead author is Seyda Fatma Rafiq, and our other authors are over here. These are our male students. Maybe I should make them a different color. Okay, so these are our students. So that's another group. And then finally, we have two faculty members, Dr. Ibrahim and myself. Okay, so actually the first case study was conducted by Seyda Fatma Rafiq. The second case study was conducted by the other group. And then we, as the faculty advisors, we also guided our students. This is, by the way, undergraduate research, and we were quite impressed with what our students did. And we wanted to also really report the results as a new information, new body of knowledge in the literature. So we are from the College of Business and Economics at United Arab Emirates University in the small city of, small but green city of Al Ain in the United Arab Emirates, and that's our university's logo. All right. So again, the topic is vibe coding of analytics dashboards and what can we learn as lessons from this one. Okay. So I will give a background and I will show the developed dashboards. Oh, sorry, I'll give the background. I will explain the methodology, then show the developed dashboards, then talk about the advantages. First, I will talk about the advantages of vibe coding, but then I will talk about the challenges faced while doing vibe coding for analytics development. And then we have a comparative analysis of the two teams that I mentioned in the two case studies. And we came up with a list of 30 challenges using AI. And we asked both teams which of these challenges they have faced. So that's the comparative analysis part. And then there's the conclusion and future work. So let's get started. Okay, so there are two main research streams related to our current research. The first one is vibe coding at large, where the researchers report the developer experiences and challenges regarding coding using vibe coding. But again, these are not specific to analytics dashboard development. Well, has no one ever used vibe coding for data analytics? Of course they did. That's the second line of research, which is they used vibe coding for automatically generating dashboards. So they just generate the code for the dashboards. And there are also some studies here. So these studies, they are using vibe coding for analytics dashboard development. And these studies, they are talking about challenges and experiences of vibe coding. But what about the the practical projects? What about the practical project experiences for vibe coding of analytics dashboards? So it's like some of this is not addressed here, and some of this is not addressed here. So ours is addressing the gap. Okay, so there are two case studies, and we have a list of 30 challenges that we use generative AI to generate. And then the students, our student teams, they always used R. R, as you might know, is a statistical programming language. Okay, I know Python is very popular for data science applications, especially for deploying data science applications. But R is also very, very popular if there are many statistical techniques used. Even though we did not use too many statistical techniques in these analytics dashboards because it was mainly descriptive analytics, still in our curriculum, we are teaching R as the primary programming language. So that's why they developed the two software using R, and the user interface for R applications is done by a library called Shiny R or R Shiny. So those are the two main components. So R is the programming language, Shiny is the library package for creating user interfaces in R applications. And for generating the code, the student teams used ChatGPT 5 and Cloud Sonnet 4.6. All right, so this is the research process. We decided the topic and we identified the gap, and then we assigned the two cases. Dr. Ibrahim assigned, I assigned the first case, and Dr. Ibrahim assigned the second case. And then we found the relevant data sets and we gave it to the students, and the students developed these dashboards. Then was the lessons learned stage. Okay, for every project, one of the project management principles is for every project, the lessons learned, the lessons captured through this project should be well documented. And so we asked our student teams to document their lessons that they learned in these two projects, which are also the two case studies. Okay, so the first case study is Dubai real estate. We had a real world data set directly from Dubai government itself about around 24,000 residential properties. The data set originally was CSV file, but then we converted to Excel file. We did manual cleaning, and then these are some of the key attributes. And the AI tools used were both ChatGPT and cloud. In the second case study, there was a synthetic data set which was generated by OpenPixel Python library, and it was an Excel data set. And these are some of the data fields, and only ChatGPT was used. So there are again two case studies. The first one is Dubai real estate, and the other one is retail customer experience. Both of them are tabular data sets. Even though there is text fields, we did not do text mining at all. We only did tabular data analysis. Okay. So for the Dubai real estate case study, there was a multi-tab R Shiny app with reactive sidebar filters. Then we had these different KPIs computed and visualized, and there were different type of visualizations. And one thing that I really appreciated our student doing was automatic generation of the report of the and then automatic and dynamic generation of the report. So if you upload a new data set, it generates the report for that automatically right after the analysis. And it also gives some executive summary as well. So this was very nice because I love automated auto ML. I love auto ML, automated machine learning, automated data science. I love those things. So this was a really nice feature of that first case study. And another thing that I really liked that this first team did was that they also implemented color themes for the colorblind people. So they used some specific themes predefined in R, and they really it was a really nice application. And the second case study was retail customer experience. And again, actually, pretty much, both applications are doing pretty much the same thing, but with different data sets. Of course, the type of analysis is also different. For example, here there was stacked bar chart. So let's just take a look very quickly at the apps themselves. So you can see here the first app, Dubai Real Estate Dashboard. So this is the full dashboard. As you can see, it's basically a working software, and it was coded using vibe coding. And here's another screenshot. As you can see, it's doing all the primary basic analysis for that, and it could easily be actually deployed. And actually, we even say who developed this software. She also presented a similar software that again she developed in one of our top trade exhibitions in Dubai. It's called GITEX. So it's a very, very good, and it was one of the many people were interested in it. So it's very impressive that within a very short time frame, such advanced analytics systems were developed. Again, these are more screenshots from the first application. This is the automated data export and report export. And this is the UML activity diagram. I will not go over this. It's in the paper. It's just I generated the UML activity diagram also. Now, the second application is retail customer experience dashboard. Again, as you can see, it's a very user-friendly and very intuitive application. And again, it was developed by Vibe Coding. And this is the UML activity diagram for this software. So what are the advantages
Sorry
of
to interrupt.
how many
Sorry
minutes?
to interrupt, sir. You have only 1 minute left to conclude.
1 minute, no worries. What are the advantages of Vibe Coding? Lowered barrier to code. It's much easier to code, and the errors are explained by AI, and some functions that we may not be aware of in R, they are suggested by the software. Especially, this is really important especially in analytics, because there are so many different type of analysis that could be done, and the repetitive tasks were really speeded up. And especially when it comes to user interface decisions, like which type of color scheme to choose, which type of layout, which type of charts, user interface decisions were also supported. What about the challenges? There was I'll just show the challenges by red color. Okay, so there was a false sense of understanding. Just because AI is doing everything, we think we are doing it right. Not necessarily. And the AI itself is sometimes overconfident. And we realized that there has to be only a single programming language. We shouldn't have R plus JavaScript. No, it's not good. This is really important for analytics dashboards. And we should not skip the documentation. That's a challenge. And we may lose what we are doing, and then we have to, we have to go round and round in circles. And of course, the AI may have some usage limits. And then we generated these list of challenges using AI, using this prompt. And these are the list of challenges generated by AI. Then we got some user feedback for this. I will not go over these because I'm running out of time, but you can read these in the paper or in the presentation. So these are the experiences of each team. And we even, asked each team to, mention, how much they experienced that. And we found the most frequent challenges. Okay, these are the most frequently encountered challenges. I mean, the highest degree of encounter, and there are also some divergence. Also, these are the challenges where they diverge. So that's some of the analysis as well. And we also have coding technical challenges. That's another part of it, but that we didn't put into the paper. We have a supplement. In the supplement, we mentioned 13 different coding technical lessons learned specifically for analytics dashboard development, and all these are functions. It's a really nice technical reference material. So that's our case study. Those are our two case studies, and we applied vibe coding for development of analytics dashboards. And the lessons that we learned from two case studies, we shared them here with you today. Thank you so much. Do you have any questions?
I have a question. How do you verify the correctness of AI-generated KPIs, filters, charts, and reports?
Yes. Okay. So as far as I know, there was not a direct verification of the validation of the results. So we did not build a separate SQL command. But what I know is both teams, they did go over the code. They did not just take whatever given and then just do it like that. They went over and over it again. Does it make sense? I mean, even though they did not build the what do you call it, the alternative standards calculation methods such as an SQL query or accounting algorithm. No, they did not do that one as far as I know, but they did go over what the code is doing and the results. Do they make sense? And yeah, and also are the charts consistent within each other as well. So that's what they did. So validation and verification could be done algorithmically or in comparison to the standard data science calculations. Yeah, that's a possibility.
Okay, no more question from me. Thank you.
Thank you. Thank you.
Ma'am, do you have any question?
No, thank you.
All right then. Thank you so much. Have a very nice day, and thank you for your questions and for listening to us. All the best.
Thank you so much, sir. Thank you so much, ma'am. As we come to the end of this technical session, I would like to sincerely thank all our authors for their excellent presentations and valuable contribution. I also extend my heartfelt gratitude to all the participants for being a part of this international conference. I hope today's session has been informative, engaging, and enriching for everyone. On behalf of the entire team, we thank you for your continued support during the 10th edition of World S4 2026, as well as throughout the previous 9 editions of the conference. We look forward to welcoming you again to the 11th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference publication will be available within 7 to 8 months. We kindly request your cooperation with the World S4 2026 team throughout the publication process. I would also like to express my sincere appreciation to session chairs. Firstly, Dr. Napat Sukton sir. Sir, would you like to share any remarks and reviews about today's session?
Okay. I would also like to thank all the participants for their excellent contributions and for sharing their research with us today. My special thanks go to my fellow session chair, Professor Priyanka Verma, as well as the moderator and technical support team for helping the session run smoothly. Thank you for joining us and wish you all the enjoyable continuing of World S4 2026. Thank you very much and have a wonderful day.
Thank you so much, sir. Uh, Dr. Priyanka Verma, ma'am, I would like to request you to please share some remarks about today's session. Ma'am, your mic is off.
Sorry. Yes. So, Dr. Nabat, it was great co-chairing the session with you. And
It's my
to all
pleasure.
the participants, all the presentations are really good and they were quite enriching. Thank you so much.
Thank you so much, ma'am. Now I would like to share the certificates. On behalf of Team World S4 2026 Global Knowledge Research Foundation and our partners, please accept the certificate as a token of our appreciation for your valuable support and contribution. Dr. Napat Suptong, sir. And Priyanka Verma, ma'am.
Thank you so
Thank you very
much.
much.
Thank you once again for your valuable presence and participation. This concludes our session. Before we end, I kindly request everyone to switch on their cameras for a quick group snapshot of our virtual conference. Please switch on your cameras. Thank you so much, everyone. You may leave the meeting.
Thank you so much, Sampriti.
Thank you very much.
Thank you so much, ma'am.